Welcome to PowerShell IoT, what .NET Core has done for your Raspberry Pi. Or if that's just too many buzzwords for you, the poshberries taste like poshberries. My name's Eli Hess. I work as a DevOps engineer for a company out in Minnesota called NetGain Technology. We host for the medical community. I work on config management for about 2,000 plus machines that are virtual, like 15,000 that are physical. A lot of fun. Before we get started, I thought I'd get a feel for where you guys are at. Who here owns a Raspberry Pi? Nice. Who here has taken that Raspberry Pi out of the box? All right, okay. Has anyone done anything they're particularly proud of that they'd want to share with the group? Any fun projects? It's a fun project. You?
I've wired it into remote control cars to kind of take over, instead of using the remote control car electronics, use a Raspberry Pi to control that, just drove it through an SSH shell.
Nice. That's really cool. Myself, I'm in the middle of a project that I'm hoping to be proud of when it's done. I had wanted to get it finished before I came here, but it didn't quite work out. I'm trying to turn my dog into a Bluetooth beacon. See, I'm incredibly absent-minded. I'm the guy that puts the tea on and then walks away, and 5 minutes later I hear it whistling and go, oh yeah, I was making tea. So I thought I'd do the same thing to my dog because I put him out in the backyard and go back to coding or whatever, and I forget that I let my dog out. But unlike the tea kettle, he doesn't whistle when he's ready. He just stares passive-aggressively at the door and freezes. So I'm going to turn him into a Bluetooth beacon, and then when he hits that proximity alert, I'll send a push notification to my phone or something like that. If you follow me on GitHub, I'll put the code up there when I'm done and maybe blog about it or something. Today, what we're going to cover is a brief history of PowerShell Core on ARM, according to me. Cross-compiling PowerShell Core for your Raspbian, imaging an SD card using semi-pure PowerShell, creating a headless Pi at first boot with an encrypted PSK, just using .NET, and then using PowerShell Core to set up a TCP server for some sort of janky PS remoting. As you can tell, most of the things we're doing today have a little bit of a qualifier on them, like all home automation should. So actually, before we get into the demo, I'll just go over the history here. About 6-7 months ago, I was getting really excited about all this cross-platform stuff. And I thought, well, if PowerShell can run on Linux now, it should be able to run on my Raspberry Pi. So I hooked up my Pi and started Googling. I couldn't find anyone who had been doing this. And so then I headed over to the Microsoft repo. And they flat out said it's not supported. But I thought, well, it's not supported, but that doesn't mean it won't work, right? So, I'm assuming you guys are like me if you're in this room and you like to tinker. So I cloned the repo down to the Raspberry Pi and popped over to the Linux build instructions. And I kid you not, the very first instruction on the Linux build is install PowerShell. Because they took the software that you're trying to compile and used it to compile the software that you're trying to compile. So I was like, well, it probably doesn't actually need PowerShell. Maybe it's just a build wrapper. So I opened it up and expanded out all the functions. And yeah, it didn't need PowerShell to do anything. They were just making it convenient. And in their defense, everywhere that it's supported to compile, it's also supported to be installed. So it was just me being an idiot trying to do this. So then I started stepping through all the build steps. And I made it as far as installing the .NET Core dependency, because .NET Core, the SDK, is also not supported on your Raspberry Pi. Because what kind of an idiot would try to compile things on their Raspberry Pi? Last I checked, it's still not supported. I think the latest info was in January. They haven't said what they're running into, but yeah. So then I thought, well, OK, I can't compile it here, but maybe I can compile it somewhere else and copy it over here. So I popped open an Ubuntu 1604 box, repeated all the steps I had just done, swapping in a couple variables, removing some of the hard-coded you can't do this things, and got to the end. It compiled clean. I copied it over to my Pi, installed some dependencies, clicked go, and the PowerShell banner spread across the screen, and I was like, I'm brilliant. And I had about 2 seconds of feeling good about myself before it hit a segmentation fault and crashed and burned. Never even got to a prompt. I popped over to the repo to submit it as an issue, and somebody, Steve Desmond, any chance you're in here? No? OK. He had beat me to it by a couple of weeks, submitted the issue. Joey's team took a look at it, and it was maybe a month later that it was compiling clean and runnable on a Raspberry Pi. They posted the instructions to do so right there, which you won't find anymore because they've made it even easier for you to do this just by posting an experimental build right on the repo. So even though you don't have to cross-compile anymore, and you can just download that experimental build, this is PowerShell Summit, and we deep dive. So we're going to walk through that. It involves a lot of internet access, and they warned me away from internet access related activities. So I took a video of me doing this. I've got it playing at 2x speed because it takes a couple minutes. Let's see if it will run. Nice. Okay, so I think it just skipped that first command. What it's doing is adding the repository key, Microsoft's repository key, to your local store so that after you've downloaded the package, it can confirm that that's the package you downloaded. The next command there is adding the Microsoft repository to the list. And then you need to do an apt-get update, which updates what's available so that you can then install PowerShell like they had initially told me to. So list updated and install PowerShell. Now I'd highly recommend all of you go about and do this even though you don't have to anymore. I learned a lot by going through the compile process where you're living in a really cool time where Microsoft is actually open sourcing their products. So I mean, take them home, tear them apart, you know, swap out commandlet lines and see what happens. All right. PowerShell has been installed. Repo needs to be cloned. Next, you have to do a recursive clone because they have a sub-repository linking out to Google test repo. It just takes a second there. And once you have finished cloning the repo, right there at the end, you can see the Google test repo. We're going to start the bootstrap. And here I realized I should probably run it with elevated permissions, so I back out and do it one more time. Okay, so they're importing that build script I told you about. It's fun to peek into that and expand it and see what it's doing. And then we start building the dependencies. Now this is just going through installing native binaries, checking to see if .NET Core is installed, and if it's not, it installs it. I'm going to skip ahead here because it takes a bit. It's also checking to make sure you're not some kind of idiot trying to do this on a Raspberry Pi and stops you if you are. And .NET not found, installs .NET. The version on Ubuntu comes with the SDK. If you guys are into development, this is also how you'd go about developing software for your Raspberry Pi. You'd want to install .NET somewhere else and then cross-compile and copy it over. Are there developers in the room? Cool. I have a recommended book at the end of this for those of you who didn't raise your hand. It's just a massive compendium on C# .NET development, but it's by far the best thing I've read. With a micro framework?
Yeah, so they've, I think it might be a little bit past its sell by date now, but certainly a few years ago, working with these small IoT devices, there is a subset of the .NET framework
Sure.
tools with integrated with Raspberry Pis, but I'm just curious. Whether you've
I haven't looked at it yet. I'm definitely going to when I get home, because that sounds really good. I was excited about the Microsoft guy who presented the Lightning demo the other day too, if you guys saw that, where he was turning on lights and working with sensors. Since I didn't have my whistling tea kettle dog ready, it's cool that he brought some gadgets into the game. All right, so this finishes up, and then you run the build. And once again, I'm going to skip ahead through here. The build process is really interesting because they're actually taking the native binaries in Linux and putting hard links into the compile. So if they're not there, the compile completely fails. And it's important for another reason, which I'm going to circle back to once we're actually on our Pi. And I'll just skip through this here, because we have a lot to cover and less time to do it in.
What was the book you recommended?
I've got a slide for it that I'll pop up. This last command I'm running here is get ps output, and I'm just running it to show you that once it's done, you can access where PowerShell was compiled to really easily with this command. And then below it here, you can see this Tcpip command. If your Raspberry Pi were online at this time and ready to go, you could run this to copy it right over to your Pi without any fuss at all. Okay. Now we have our Pi. Let's talk about imaging our Pi with .NET. I made a module for this. It's up on the PowerShell gallery called Poshberry Pi. And with this module, you can actually image and back up your Raspberry Pi. All right. And I'm going to get this going because it takes a minute. No one likes to wait for progress bars. And there we go. So some of you who have done more than plug your Pi in are probably wondering, why would I do this? We have Etcher, we've got Win32 Disk Imager. What's the point of putting the imaging into PowerShell? Well, on the one hand, I find myself doing these weekend projects all the time and coming up with like application bloat where like 3 months later, I'm going back to my add remove programs and going, oh, what did I even use that for? And having to uninstall things. So this reduces that. And on the other hand, I wanted to see if I could. And again, not only can I do it, but it's just as fast as Etcher, Win32 Disk Imager. It could definitely use some cleanup yet. I've got it to the working state, but not to the like really polished state. And I've expanded the code out here from what it's doing. Like I said, it's all up on GitHub in a nice, pretty module with error handling. More that's going to be present here and all that. So right out of the gate, you can see why I called it impure PowerShell. I'm doing an add type on a Win32 disk access object that is handling some native calls for me to grab the disk handle and lock the volume, that sort of thing. I think I can do this with just .NET objects tapping into the interop assembly, but I haven't tried that yet. And then we initialize some variables, check to make sure the image exists. Here, I'm making sure that you're not running against the system drive, because that would be awful. And I also put a hard stop in if the volume that you're targeting is not empty. After hearing Bruce the other day, I feel like I should add a force parameter for this so that I'm not going to hold the gun, but if you want to shoot yourself in the foot and format over something, then you can. And then we get our disk access. And if everything checks out, we start working with our stream objects and readers. Since not many developers are in here, you probably aren't aware that the stream class in .NET is like the base class that all I/O operations happen on. So it's an abstract class, meaning everything else is inheriting it. And they've got streams for file, network, memory, cryptography. You name it, they've got a stream for it if it's I/O. And because they do it that way, they're all pretty similarly worked with. All I'm doing here, I'll talk about this Control-C thing in a minute, is initializing a buffer initializing the stream with the file name, the mode I want to open, and the access I want to give it. And then I pass that file stream to a binary reader to do all of my I/O. Back to this Control-C thing, I wanted to be able to, break out of this if I decided that it was bad, and we just finished here. This format that pops up is because one of the partitions is a Linux partition and Windows can't read it. Yeah, so I want to be able to break out of that if you decided you didn't want to format this image, or if you were doing a backup, you wanted to break out of your backup. And you can Control-C out of that by default, but it doesn't recognize that you've Control-C'd out of it in any fashion that I was able to then release the disk handles. So if you run console treat Control-C as input as true, then you just, every iteration through your loop, check to see if somebody's pressed a key. If it's Control-C, you flip a flag, and then you can handle whatever it is you wanted to handle at the break. The loop itself is looking to see if, as I'm moving through the file, where's the offset at? Like, what position in the file am I at, and has it hit the file length? And if so, then you're done and everything is good. Read bytes, like I said, you pass it a buffer. Offsets where you want to read and how much you want to read. So it fills up this buffer, does some validation on the content of the buffer. I'm not going to get into it because it gets technical quickly. And then writes the buffer to my SD card, and then keeps going through. And as it's doing it, we've got some progress reporting. And in the end, as I said, we need to release the disk and all of that. And now once we have our imaged Pi, how are we doing on time? The next step in interacting with your Pi is making it headless. You can do all of this after you've plugged it in and logged in and all that. But as much fun as it is to interrupt my girlfriend's Sunday afternoon Netflix binging by plugging my tiny computer into the TV and sitting in front of it with a keyboard, I thought, do it all remotely if possible, So the makers of Raspbian have actually made this really easy for you. Initially, all you have to do to enable SSH remoting is make a file on the boot volume that's just SSH, no content. So this commandlet is not impressive, but it exists. And this next one, enabling Wi-Fi, is a little bit more impressive. Because enable Wi-Fi, you can just put the WPA supplicant.conf file on the boot partition. And with your Wi-Fi settings, and it'll grab them and start them up right away. But you would have to put your password in plain text to do that from a Windows machine. Linux, they have this command, WPA passphrase, that does the encryption for you. I'm going to show you the output of that in a second. But I need to actually run this, don't I? On Windows. So the username for this is just the SSID of my network, and then password if I type it in correctly. Yeah, so what it's doing under the hood is first it, as a salt, does an ASCII byte array of your SSID. It then passes that to this RFC 2898 derived bytes object with your password in plain text. No, that's not my actual password. Please don't hack my phone. And how many iterations to use to then derive the key. You then take that object. It has a get bytes function on it. You tell it how many random or pseudo-random key bytes, according to the white paper, you want to pull from that, and it just pulls these bytes, which are then converted to a hex string, and the output looks like this.
Is 4096 a significant number there, or is that just random?
That is a significant number. That was what I found Linux to be doing under the hood, which wasn't all that easy to find. I had read a lot of really boring security white papers on this particular Sunday afternoon. The file output just looks like this. You're telling it control interface, what group has access, country code. I made a thing that you can change, SSID you can change, pre-shared key, and then your key management you can also change. And the most important part is when you're outputting this file to your boot drive, you need to fix the line endings to be Linux-style line endings and encode in ASCII. So this should mean we have a headless Pi here. If it doesn't, I have a pre-baked headless Pi that we can patch into. And take a second to power up, and because it's on my phone, I found a net analyzer app that's really nice for when you're using your phone as a Wi-Fi hotspot. Any other questions while we're waiting for it to boot up? It should just take a second.
Having thoughts about extending the dog after you've automated, perhaps getting the dog to automate the kettle, perhaps?
I haven't thought about getting my dog to participate in the automation. I've thought about cutting a hole in the door and maybe switching to an RFID or something that just opens when he gets to the door. Once again, I don't know that my girlfriend will be very keen on me cutting a hole in the door. So we have joined the network and should be able to hop in. I'm going to first copy over PowerShell from the previous video. This is the copy of PowerShell that I compiled. And create directory. And we'll hop over here. All right. Accept the host key, default credentials, and like I said, please don't hack me. So I can now show you the Linux version of that WPA passphrase. And you can see the outputted key is the same one that I've got down there. Quick scanning. SCP is almost done here. While that's going on, I also need to install the prerequisite here. Hopefully this worked for me. I was running through this demo this morning and the repo was not available or something. I had to switch to my pre-baked. Nice. All right, so I'm going to hop over to PowerShell and give it a run. Nope. First, I'm going to extract it. All right, now I'm going to give it a run. Demo gods be good to me. So it would be right here where the banner came across the screen and then we hit the segmentation fault. And I'm just waiting for it to do it. There we go. Yay! Thank you, demo gods. All right, now we get to get into the fun stuff. And fun stuff, I mean, this is code that I took elements of from a blog that Bo Prox did on TCP server scripting. I've stripped out the authentication bits, which you will definitely want to add back in if you decide to use this anywhere other than your home lab, because it's just a wide open thing for anybody to run whatever they want if they know this exists. Don't tell Lee. So right out of the way, we can just do install module, Poshberry Pi. As I said, it is on the gallery. I would love it if you guys contributed, make changes, help me out here. If it becomes a Raspberry Pi module, that'd be fun. That lots of people use other than just me. Otherwise, I'm going to keep using it. And should give me that trusted repo error in a second here. Any second. Everything runs just a little bit slower on your Raspberry Pi. But you got to give it up to the PowerShell team because all of this is just so easy. All right, so we have our Raspberry Pi. Let's make it a TCP server. So right there, what I have done is defaulting to port 1655. You can change that to whatever you want. I create a listener using the sockets class. Fun fact, the sockets class was actually made for Unix machines, and Windows adopted it. Listener.start opens up the port to start listening for incoming connections, and then we enter our loop looking for data. Now, this call I'm doing here, accept TCP client, is a blocking call, which means after I click go on that, I'm not going to be able to do anything else on the console because it's just sitting there waiting and listening. There's an asynchronous version of this call that you can, and I probably will implement in the future. I just wanted to keep it simple for the purposes of the demo. And if it were asynchronous, then you could go back to doing whatever you want, and the TCP server would just run in the background and wait. You'll see some familiar objects here. Stream, as I said, the base object for all I/O. So create one of those, do a get stream. As soon as data is available, it does the read, like last time with the file I/O. You're passing it a byte, where you want to start and the length of the byte to read into. And then we're using a Stringbuilder object, which is another really fun object in .NET. Because if you don't know, strings in .NET are immutable. So any string manipulation you do is actually destroying the original string and creating a brand new one with whatever you've done to it. This is really important the more manipulation you plan to do with that string. So if you're building out really long, complex output or commands with a lot of appends, doing a lot of manipulation like that, the I/O actually adds up pretty quick. You get memory-intensive, slow applications. Stringbuilder was created to help us out with that, where anything that's happening to it happens to the exact same block of memory. And then once you're done, you just do a toString on your Stringbuilder, and there you have it. You get your string command. So it's listening, it's building a string, and then once it has it, it does a script block.invoke on that string and returns the data to variable data. We then serialize that data, get the bytes, and write it right back into the stream. We're able to do this because, in this case, I know every time I run a command against the server, there's going to be output. It's going to come back. I'm going to be listening. I think the IP was 208. Is that right? So I'm going to do Invoke Pi Command against my Pi. And you can see my command that I was passing was write output, hello world, and return to me was hello world. Back on the Pi, once it's running in verbose, we can see exactly what happened. It accepted this new connection, looked at how many bytes were available, read them in, made sure that the bytes that were available were received, ran the command, serialized that, and then echoed it right back to me. The Invoke Pi command looks really similar to the server command. You're just creating an endpoint, which is a socket underneath it. TCP, the protocol, doesn't really have a client-server memory to it. Once the connection exists, it's just two streams talking back and forth. So a lot of this stuff looks identical. So in this case, I'm encoding the command that I'm passing, writing it to the stream, going out, and then immediately putting up a blocking wait to see what's coming back, because I know the server is going to toss the output back to me. It gets the output, again, using a Stringbuilder, slices it all together, and then deserializes that data to get me the typical deserialized objects that you get when you do any PS remoting. I can prove this here with this one. So now I'm, nope, if I put the right IP in. Now the command I'm running is get process pwsh, which is the new PowerShell process. If you look at get member on that output, you can see deserialized system diagnostics process. And that's what it looks like. It just looks like get process. An important difference here is that a difference in running commands on your .NET Core Linux version of PowerShell versus your other ones are aliases that you might be really used to using do not behave the same way. So like this is, I said I'd be circling back to the native binaries that are being used. Things like ls are actually running ls on a Linux machine, which means you are not getting a bunch of file info and directory info objects back when you run that. You're getting string, just a string object that you could then parse like you would before, but it's not going to behave the way that you think it would in PowerShell. And I can show you this. Let's do ls. All right, so output. It's a get child item of where PowerShell is running, but it's not actually get child item, it's ls. Nope. Under the hood, string object. So if you wanted to get child item, you actually need to run get child item. I think a lot of scripts are going to need to be updated out in the wild because of things like this. Any aliasing that you have floating around in your scripts should get stripped out, put in the actual commandlet. We hit a snag, and I'm not sure why. Another reason not to use this in production. There's case sensitivity issues that I found. Might be able to get away with just running it again. No. Broken pipe. Interesting. Let's try. Shutting it down and starting it back up. Oh yeah, things are not happy. Okay, that's going to reboot because something went wrong there, like it does in a demo. Any questions so far? How are we doing? Lots of fun. You, sir.
I guess I have one question. So for passing commands, would you be able to like pass device commands as well? Like let's say I plug like a game controller into a Windows box. I want to be able to pass its cycles through the server to the Raspberry Pi to have control motors.
Yep.
Robot.
Yep, you can absolutely do that. I've remotely shut down my Pis with this. Anything you could normally run natively, you could do. You could kick off Python scripts if you've got them set up that way. It works pretty well. It needs some love and some little bit of TLC because of the asynchronous stuff needs to be fixed. You need to add authentication back in if you're going to put it anywhere other than your house. But it's a fun little way to do some PS remoting on your Pi. I'm surprised no one has asked this question yet. Why not just use the native PS remoting on your Raspberry Pi? I actually tried to set it up. And when I initially set out to do this, they hadn't even talked about native remoting using SSH in PowerShell yet. So when they brought that up, I was like, oh, well, that eliminates the need for any of this. But I tried to get it set up, and I couldn't get it working. It could be user error. If anyone has got it working, you can raise your hand, and I'd love to talk to you afterwards. I've also heard there's some weirdness with sudoing in PowerShell remoting to just regular Ubuntu machines. Someone told me that wasn't working quite the way you think it is. Like it says it's sudoing, but it's not really sudoing. So there's still some bugs to be worked out, and I'm sure there's a whole plethora of Git issues out there doing so. All right, I think we can restart this session. Oh, what I should have done before I did that to show you guys this is if you just want it running anytime your Pi starts up, it's really easy to do with cron tab. Cron tab-E for scheduling. There are a half dozen different ways to have something start up when your Pi starts. I found this one to be the most intuitive. I'm using Nano as my editor. And then this command here to get it going. So what that's telling it is at reboot, run elevated version of PowerShell, no exit, non-interactive, and the command is just to start the TCP server. Control-O and Control-X gets you back. So if we hop back into PowerShell here, let's see if I can finish showing the getChild item. As you can see, everything just shifted to the right. I don't know why it does that. And there we go. So getChild item versus ls object. You're actually getting directory info objects versus the string output to finish off that point. Any more questions? Are we doing good? All right. We're actually busting through this faster than ever. Nervous talking quickly, I guess. The recommended reading I was telling you about is up here. I'll get it nice and big for you. Yep. And no problem. Okay, so the big book is C# 6.0 and the .NET 4.6 framework. As I said, this thing is massive. Weighs probably 5 pounds. It's just wonderful. Like honestly, I think if you really like PowerShell, you should be moving in this direction because the more complicated your scripts get, the more you end up interacting with these base .NET objects. And even if you just stepped through this book to feel more comfortable with .NET, even if you weren't going to try to become a C# programmer, it'll teach you things about what's going on behind the scenes that will help you in your debugging, in your troubleshooting. It'll make your script writing more elegant and efficient. But yeah, it steps through all the way from the beginning of this is, you know, how to make an if block, all the way to the end where you are creating WPF, you know, GUI things. I know GUIs are bad, but WPF GUI forms. You've got SQL backend stuff that you're hooking into, and Windows Communication Foundation. It just taps into like, I want to say surface level, but it actually manages to give you a pretty comprehensive overview of like every area of .NET. It's really good. This next book, TCP/IP sockets in C#, is I want to say about 15 years old now, and it's still very relevant. It was written for a college program of some kind. It's only 200 pages. It's a really easy read, and it has you doing stuff like I was just doing, where you're setting up TCP servers. It talks about setting them up asynchronously, and yeah, you get into a lot of peripheral things within TCP/IP, and it goes over the framework itself and how the internet works, you know, how all of your communications are going, which is, again, like, we should be, you know, learning the back end if we're going to be tinkering with the front end. And that last link, which I did not expand out for you, is the blog that Bo Prox did about building a TCP server. It's a really good blog. He starts with just the base element of like opening up a socket, and then you can, you know, run a netstat to see that your socket's open, create a connection, go through. It's a good blog. And then steps through it. So I'm really grateful for him doing that. And that's all I have for you guys. So if you don't have questions. Thank you.